So hello my dear students, now next lesson we are going to learn for the second sem as combustion and flame. So for the first sem till 9th lesson we completed. Now for the second sem we are going to start the new lesson, that is the combustion and flame. So about the combustion and about the flame. So you know about what is combustion. Means here anything burning, yes, it is our in always mind, if anything burning there is a combustion taking place. Means why there is a combustion, what is necessary to burn anything, about that also we have to see. So here as you know there is a combustion and flame. For the combustion, if you saw any different kinds of means which things are going to burn, think about that first of all. Like if you are taking a paper, it is burning. If you are taking a wood, it is burning. There are different fuels are there, like petrol, kerosene, diesel, different LPG gas. As you know, they are going to burn. So they are, that is called as a fuel, and we are using a fuel for the different purposes which gives the heat and light, which produce energy. For that purpose, as you know, LPG gas is there, so it produces a heat, and so cooking is taking place. And there are the different again things are there which are producing a heat and light. If we are burning wood, it produces heat and light both also. So different kinds of fuel have used in a various purposes at home, in our industry also, and for the running automobiles like a petroleum diesel. Petrol diesels are there, we are using for the different purposes, like for automobiles, for the vehicles running also. So the few fuels, like as you know, as I told about the petrol, diesels are there, otherwise in home LPG, kerosene gas is there, wood is burning, and so paper. So these are the common things you are observing always in your home also. So here what fuels are used for running automobiles, like a petrol, diesel. You know before means now also in means in whose home there are the cattle are available, they are using cow dungs also, and here wood, coal, so they are using that one and they are burning that, combustion is taking place. So these are the different types of fuels are there, like a cow dung is there, coal is there, petrol, wood, diesel, kerosene, compressed natural gas, that is a CNG in our home we are using. So these are different types of fuels are there. Burning of a candle also, you know, when we are burning the candle there is a producing a heat and light. What is difference between burning of candle and burning of a fuels like a coal? So about that also we are here, you observe that here candle burns with a flame where coal does not. You know that whenever we are burning a candle it produces a flame, but coal is not producing a flame. That is the difference is there we are observing. So it is a burning, coal is a burning without a flame. So about the different materials we are going to see. Now first of all, what is combustion? So as you know, taking a magnesium ribbon and burning that magnesium ribbon, so it will burn very brightly, and as there is a formation of here ash is there after burning. So here that is activity is there in the class 7th, you learnt about that. When we are burning a magnesium ribbon, there is a formation of magnesium oxide and produces a heat and light. It will burning very brightly and it produces a heat and light, and also after the burning it gives the here magnesium oxide. So Mg plus O2, there is a formation of MgO2, that is called as a magnesium oxide. We can here perform a similar activity with a piece of charcoal. Hold a piece with a pair of tongs and bring near to the flame of a candle, and that is a Bunsen burner. Bunsen burner means it is like this type of a burner is there which is available in the laboratory. It has a connection giving. So here that is the gas connection is there, and so that is a Bunsen burner is there. Here you are observing that we find charcoal burns in a air, charcoal also burning in a air. How magnesium ribbon we are taking and burning, it produces a heat and light, and there is a formation of a magnesium oxide. Like that here there is, when we are burning a charcoal burns in a air. We know that coal also burning in the air, so producing a carbon dioxide, heat and light. So here it will produce also when coal is there, charcoal is there, they are also burning in the air and they are producing a heat and light, and also there there is a formation of here carbon dioxide gas. So then what is a combustion? It is nothing but a chemical process. It is one of the chemical process in which a substance reacts with the oxygen to give off heat. Whenever substance is there, it is reacting with the oxygen and it gives off a heat. Here, there the substance is necessary, it reacts with the oxygen is necessary and it produces a heat, that is called as a combustion. It is one of the combustion is one of the chemical processes there, because from one substance there is a formation of the another. Whenever a new substance is formed, that is a chemical change is there. So combustion is a chemical process where in which a substance burn in the here or burns or reacts with the substances are there, react with the oxygen, burns in the air or burns in the presence of oxygen to give off the heat, and there is a formation of a heat. It is called as a combustion. It gives off a heat. The substance that undergoes a combustion is said to be a combustible substance. So the substances, all substances are not burning. Some substances are there, they are able to burn. So the substance that undergoes combustion, the substances which undergoes for the combustion, which are able to burn, that are called as combustible substances, and it is also called as a fuel. Combustible substances like wood, coal, charcoal is there, petrol, diesel, kerosene are there, cow dung, these all are there, they are called as also fuels. Not only the combustible substances, they are also called as fuels. The fuel may be in solid, liquid or gas form. So as you know, wood is there solid form, kerosene, petrol, diesel in a liquid form, LPG gas is there, that is CNG, compressed natural gas is there. So they are in the gaseous form is there. So sometimes light is also given off during the combustion. During the combustion there is not only producing a heat, sometimes there is a production of a light is also there. So either as a flame or as a glow. So candle when we are burning, there is production of a light also, not only it is producing wood when we are burning, there is a it will produce a heat and light. So sometimes when substances are burning, it produces heat and light also. In the reactions mentioned above, magnesium and charcoal are combustible substances. So as we saw the magnesium ribbon when we are burning, here on the burner when we are holding, there is a formation of a magnesium oxide, and also when burning a charcoal there is a formation of a, or it produces a carbon dioxide, and also it produces a heat and light. So they both are the combustible substances. The substances are there, these substances are combustible because they undergo in a chemical process and which reacts with oxygen to produce a heat. So here is one table given, that is 10.1 activity, the substances which are combustible and which are non-combustible. As you know, if you are taking iron and burning, is it burning? No, so that is non-combustible. So common things are there. If you are taking a steel, copper, yes, metals are there. If you are holding that one on the flame, on any burner, they are not burning. So they are non-combustible. So as you know, this table is a very easier one. You should write there which are combustible, which are non-combustible. Example, wood, paper is there. They are combustible gases. Iron nails are there, otherwise any iron things are there, they are non-combustible. Stone is there, it is also non-combustible. So glass, non-combustible. So these are the some common things are there which are non-combustible. As you know, which are burning, which are able to burn, they are called as a combustible. So here let us investigate another one condition under which combustion takes place. What is necessary for the combustion? See, what is necessary for the combustion? Combustion taking place, which things are necessary here? So we are going to see one by one activity, that is activity 10.2c. In that we are observing there is a glass is there, means transparent glass they used here. Middle one candle is there. So there are three candles are there with the help of that, or if we are taking only one candle and one glass and another one, two wooden pieces, that is also enough. Not necessary that three at a time. If we are going to observe three at a time, for that purpose you should use. So in this activity, fix a lighted candle on a table, put a glass chimney over the candle. So glass chimney is there because we want to see the candle's flame, and so over the candle you should put it and rest on a few wooden blocks in such a way that air can enter the chimney. In the first one, see, first A is there. In that, if you are observing, here is the, so here is the candle is there, and here wooden blocks are there, which in that, on that wooden block here they kept here glass chimney. So by that you are observing that if it, when we are burning the candle, it goes on continuously burning, it will not goes up. So continuously burning is taking place because from downside, from this down, there is a supply of oxygen is there. Oxygen is continuously going to supply there, it will not stop. So observe what happens to the flame. If you are observing, the candle burns freely in case when there is air can enter the chimney from below. Air is entering from in the chimney from the below. So it will burn continuously. So second one is there. Second one, B. This is about the A. One is there. In the A, what we observe? There is a, here candle is burning continuously. It will not stop. It will burn continuously because air supply is there, oxygen supply is there continuously from the down of that glass chimney. Now if we are removing this wooden block, directly only glass chimney, when we will keep on the candle, here for few seconds there is a burning of candle is there. In the B activity, there is a, it will burn for few seconds continuously, not means it will off after some time. It will burn for few seconds and afterwards here it will not burn. So that is, it will off. So here when air does not enter the chimney from below, the flame flickers and produces smoke. Flickers means here suddenly it will give the brightness for few seconds and it will goes off in the B activity. Because how much oxygen air is available for that time, here from outside there is no supply of oxygen, nothing is there in the B activity, you see. Because and so oxygen how much available here for that much time, for that much seconds only there is a burning. So flickers off means there is the candle is burning here for few seconds and means brightness it will show suddenly and then it will off become. So that is called as it will flickers off. So here in the B there is a, when air does not enter the chimney from below, the flame flickers and produces a smoke. It will burn for few seconds, it gives brightness and immediately that is producing a smoke. In the C activity, see here again one wooden block is there, they closed for the mouth of that glass chimney. So the flame finally goes off and because of the air is not available, as you know air is not available and so it will goes off. It will not burn, it will goes off. So this is the one of the activities there by understanding purpose. What is necessary here? In the first, second, third, in the first you observe there is a wooden blocks are available and so there is a burning of the candle is there continuously, it will not stop in the first one. There is a burning of candle continuously, it is you are observing because here there is a oxygen supply is there, it is continuous. But in the second one what will happen? It candle is there, it will burn and it will flicker off. Flicker off means it will burn and suddenly there is a producing of the smoke because how much oxygen is available for that much purpose it will burn or air is available. In the C what will happen? It will not burn, it will off become, means here the flame goes up and so because of air is not available. So this is one of the activity. By that activity what you understood? Here oxygen is necessary for burning the things. So we also know about the studies of producing its heat and light here and it is also some kind of a combustion. In the sun there is a heat and light are produced by the nuclear reactions inside that sun. There is a nuclear reactions are taking place and so because of that it will produce a heat and light. So Place a piece of a burning wood or a charcoal on a iron plate or tawa and cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Does the charcoal stop burning after some time? Can you think of the reason why it stopped? So like this only, take a charcoal and hold that one on the any candle flame, and after that when burning the charcoal, when start the burning charcoal, after that on that any vessel you should close, means which is a transparent one. You are observing that the charcoal is burning for some time only, because how much oxygen is available in that area, in that vessel, that much time that charcoal is burning, and then it will goes up. Here also for charcoal is there, or for any things whenever want to burn, there is oxygen is necessary. You might have heard that when the clothes are of a person catches a fire, the person is covered with a blanket to here extinguish. So whenever catching a fire, when any things are there, whenever catches a fire, otherwise any person is there catches a fire, for that person taking a blanket and wrapping that blanket, it is covered with, or that person's body is covered with a blanket immediately, because there is cut off, that blanket cut off the oxygen supply for that catching the fire. So fire is there whenever, or here body when catches a fire, oxygen is necessary to burn. If we cover up that one with a blanket, oxygen supply is cut off there, and so because of that here there is a it will stop burning. So mastic burn by itself. Does the mastic when you are taking it is going to burn itself? No, it will not burn itself. You must have had an experience of burning up a piece of a paper. We are taking a pieces of paper and burning that one with the help of mastic. Does it burn? Mastic is brought near it. Yes, when you are burning, when mastic, when we are taking and when we will start it flame, then only the catches the fire by that paper. Can you burn a piece of wood by bringing a lighted mastic near it? Yes. So wood is also when we are taking here bringing mastic near to the wood, then only it start to burn. Why do you have to use a paper or kerosene oil to start the burning of a wood or coal? Wood immediately when we are bringing a mastic and starting to burn the wood, immediately not burning. Here because we are taking a kerosene, we are taking a paper, and with the help of that paper or kerosene only wood start to burn. When big wooden is there, wood is there, and we are taking a mastic, and here we are bringing a burning a lighted mastic near to the wood. It will not burn itself continuously. It will here it is necessary to bring any kerosene or papers near to the wood to bring that one to the, or here that temperature is less, not that much less, ignition temperature, very low temperature is necessary, and for the kerosene, for the paper, there is a ignition temperature is there. So kerosene oil is there, otherwise here papers are there, it is necessary to burn the wood also here. Here as you know, you saw about the forest fires also, about that also. When there is a low ignition temperature is there, that time there is a forest fires we are observing during extreme heat in the summer. When more heat is there in the summer, there is a friction. Some places dry glass catches a fire, dry grasses are there, they catches the fire itself. So last year also you listen about in Australia, there it catches, the forest is there, it catches the fire. From the grass it spreads up to trees, and very soon whole forest. So when there is a dry grasses are there, because of a more heat in the summer season, it catches the fire. So that is called as a forest fire. These experiences which we are observing, which catching a fire at a different temperature. Why that some are there burning at a different temperature, means here wood is immediately not burning, but if we are taking any piece of paper, kerosene, immediately they start to burn. Why this is going to take place? Because it has a different temperatures are there. So the lowest temperature at which a substance catches a fire is called as a ignition temperature. That is nothing but the ignition temperature. So here in the ignition temperature, it is nothing but the lowest temperature at which substances catches a fire. There is lowest temperature. Lowest temperature at which substances catches a fire. So, because that is called as a ignition temperature, the lowest temperature at which here substance catches a fire. So, the kerosene is there, otherwise kerosene oil or peppers are there. They are catching fire because they have a ignition temperature, means they have a lowest temperature is there. Then the wood is not, when we are burning matchstick bringing near to the wood, it will not burn immediately. We are using kerosene oil, otherwise we will use their pieces of paper, then only it starts to burn because there is a necessary lowest temperature, and that is called as a ignition temperature. All substances has not a ignition temperature that much lowest. So, here a mastic does not catch a fire on its own at room temperature. Mastic also at a room temperature it will not here burn itself. Why does the mastic start burning on rubbing on one side of a matchbox? See, matchboxes are there. Here in the matchbox story is there, you should read out that story. Here matchbox is there, it is made up of the phosphorus. So, here head of a safety match contains only antimony, trisulfide and potassium chlorate. The rubbing surface has powdered glass and little red phosphorus is there. So, the rubbing surface is there, has a powder glass is there and red phosphorus is there here. And so, when the match is there struck against the rubbing surface is made up of a white here red phosphorus and the glass. See, here this is the matchbox is there, here it is the mastic is there. So, mastic is there, it has the only antimony, trisulfide and potassium chlorate, and rubbing surface is there, it has a red phosphorus and here powdered glass. When mastic struck against the rubbing surface, whenever we are taking mastic and when it will struck against the surface of that, then some red phosphorus gets converted into the white phosphorus. The red phosphorus which is present on that mastic cover, match cover, then it will convert into white phosphorus, immediately react with the potassium chlorate, and so potassium chlorate which is present in the stick, here there is this immediately react, that white phosphorus is there, first red phosphorus convert in the white phosphorus. Mastic is there, mastic is made up of here it is nothing but potassium chlorate, and for the matchbox there is a red phosphorus and glass is there. When we will rub it, that red phosphorus immediately convert into the white phosphorus and immediately it react with the potassium chlorate of that matchstick, which produces and this immediately react with potassium chlorate in the mastic to produce enough here heat to ignite antimony trisulfide, and so in that mastic antimony trisulfide is there which produces heat, and by that heat that antimony trisulfide is there which is present, which has and here it produces heat. Heat is not there, heat is also necessary. The mastic itself is not burning. Here matchstick is there, it is here on that potassium chlorate is there, and also there is the here it has a antimony trisulfide is there. So, matchstick which is made up of a potassium here about the potassium chlorate and also antimony trisulfide, it has necessary heat, and so the red phosphorus convert into white phosphorus is there, it reacts here with potassium chlorate and then produces a heat, and when heat is producing, that time antimony trisulfide is there, here it catches a fire, it ignite and start the combustion, and so matchstick is there, it will not burn itself because heat is necessary there. We find out the combustible substance cannot catch the fire or burn as long as its temperature is lower than the ignition temperature. So, ignition temperature is there, it is necessary that combustible substances cannot catch fire. They will not catch fire or burn as long as its temperature is there lower than the ignition temperature. So, here ignition temperature lower is there for the matchstick, but also there is a heat is necessary. Have you ever seen cooking oil catching a fire when a frying pan is kept as long as burning stove? So, here immediately it will not, as you know, your mother is there pouring a cooking oil in the vessel and giving a heat for the vessel that time. So, here there is you are observing that as long as it is burning the stove, kerosene oil and wood do not catch fire on the own at a room temperature. And you observe also there is a kerosene oil is there, otherwise wood, it will not burn itself. Here kerosene oil is there or wood is there, they will start itself for burn? No, they will not catch fire itself on their own at a room temperature. But if kerosene oil is heated a little, but when we are heating kerosene oil, cooking oil heating, that time it will not catches fire immediately. Yes. So here you are observing that for long on a burning stove and keeping cooking oil itself not catching the fire, but kerosene oil if we are burning it will catch the fire. That is the difference in between the cooking oil and the kerosene oil. Cooking oil not catches a fire, but kerosene oil is there, it catches a fire. If we are heating for a little, it will catch fire. But if a wood is heated a little, it will still no catch a fire, not catching a fire. When we are comparing cooking oil and kerosene oil catching a fire when we are heating a little. But when we are comparing kerosene oil and wood, kerosene oil is there when little heating, then it will catch fire, but wood will not catch the fire. Does it means there here that ignition temperature of kerosene oil is there, it is lower than that of a wood? Yes. So does it mean that we need to take a special care in the storing kerosene oil? Yes. Whenever we are keeping kerosene oil, it has a special care is necessary, because here some heat if we are applying there, then immediately it catches a fire. So storing of kerosene oil is there very much necessary here to store it carefully. The following activity shows that the essential for substances to reach the ignition temperature. So whenever ignition temperature is not there, the substances are not burning. Here is one activity, by that you are understanding what is ignition temperature. In this activity they taken here burner is there, otherwise candle is there. On the candle take a paper, make it a cone. Paper cone is there, form the paper cone, and in that paper cone before you should add a water and hold that paper cone on the candle. Another one candle take and on that candle also you should paper cone prepare and hold it on the burner. A and B activities there, which is a burning and which is not burning. Paper cones are there, this is also paper cone and this is also, another one is also paper cone. So the paper cups are these, paper cups are there when we are holding on the candle. Which one is a burning? Yes, as you know, second one is a burning paper cup immediately. In this it is burning, but what it is taking place? See, here paper cup is there, in that water is there. So here there is a ignition temperature is not there for the paper cup because of the water. Water will not give that ignition temperature for the paper cup. So paper cup is there, now paper is there, but because of water it is not it has not a lowest temperature or not a ignition temperature. So water starts to boil, water is boiling, when that will convert into vapor, and when it will goes up, then only the paper cup is there, it is burning. So here if you are observing there is here ignition temperature, it is necessary, so that it is essential for the substance here to reach the ignition temperature. Here it is reaching the ignition temperature, paper is immediately reaching ignition temperature, but water is there, water prevents here for the paper cup to goes to the ignition temperature, because water is there, that water it will use that heat for the boiling, and then it start to boil, heating, and then it start to boil, and then it convert into the vapors. And so paper cups is there, paper cup not come to the ignition temperature when water is present in it. Here no any water, so paper cup is burning. So what happens to the empty paper cup and about the here water filled paper cup is there, about that. If we continue heating the paper cup, we can even boil the water in the paper cup. In paper cup continuously when we are heating, water is boiling. So the heat is supplied to the paper is transferred to the water. Heat which is supplied to the paper it goes to the water and water starts to boil. So by the conduction method, that method is called as a conduction. So by that, how combustion is there, like that conduction method, there is heat which is supplied by this candle, it will use it and it will goes to the water for heating. So it transferred to water by the conduction method, and so in the presence of water the ignition temperature of paper is not reached. So paper will not reach for the ignition temperature because water is present. It will not reach for the lowest temperature or ignition temperature. Hence paper cup is not burning here. The substance which have a very low ignition temperature can easily catch a fire. Substances are there which has a low ignition temperature. It is a burning, it catch a fire, like this paper cup is burning. So catches fire, a flame, and are called as inflammable substances. So the substances which have a very low ignition temperature, like paper is there, kerosene oil is there, wood is there, so the petrol, diesel, kerosenes are there. So these are called as combustible substances because the substances which have a very low ignition temperature and which are easily catching the fire, they are called as combustible substances. Example of inflammable substances, that is petrol, alcohol is there, liquefied petroleum gases are there. These are examples are there for the inflammable. Means here the substances which have very low ignition temperature. You know LPG gas, immediately when we are giving the supply of or whatever, here when we are giving a very low temperature is there, and when we are giving small fire or when burning matchstick bringing near to the LPG gas, then immediately it catches the fire. It has a, so here these are the substances which have a very low ignition temperature. So wood is not coming, wood, paper, they are not coming for that. Here they are mostly here. They are also, wood is there or paper is there, they are also catching a fire. But most inflammable substances like liquefied petroleum gas is there, petrol, alcohols are there, they are catching the fire immediately. Kerosene oil is there, or also here about the paper is there. These are examples are there for the inflammable substances. How do we control the fire? So next point we are going to see how to control the fire. Fire is a controlling, you know, fire brigades are there, it will come. So how they are controlling that fire? As I told, when there is whenever any things are burning, what is necessary there? We saw air is necessary, that is oxygen is necessary. Cut off the oxygen supply, don't supply the heat there. So these are the some substance. About heat also we saw, if ignition temperature is there, it is the lowest one, then only the things are burning. So you must have seen or heard of a fire breaking out at homes, shops, factories. Many times you are listening, there is a, here fire is there, about the fire breaking in the homes, buildings, industries. If you have seen such an accident, write a short description about that. In a city or fire brigade station is there, about that see in our city, as in here it is available or not, about that discuss. When a fire brigade arrives, what